Okay, students, good morning. Okay. So last class we studied what? Basic concepts of chemistry, isn't it? So we have done some problem also. Okay. Only few concepts we have seen in the first chapter, isn't it? Next one, one chapters I am going to take. There is very important chapter. This also chemical bonding and molecular structure. Okay. So compulsory one questions will be asked, one or two, somewhat big chapter. Okay. So then only I expect 2 questions from here. Okay. So very important chapter. So what are the things we are going to study here means we are going to study about types of bonding. Types of bonding means ionic bond, covalent bond, coordinate bond, metallic bond, hydrogen bonding. These are types of bond. Next one is molecular structure. Molecular structure, if you want to study means we have 2 or 3 theories are there. There's nothing but VSEPR theory, clear? Then molecular orbital theory, then valence bond theory. Okay, this is all very important. Then only we can study about what? Molecular structure. Understood? Okay. So this is all only we are going to study here. Then one more thing, very important property is nothing but hybridization. Okay. So this is all we are going to study in this chapter. Okay. So understand the concept. So especially you must know the atomic number of element, at least 1 to 20 elements or 1 to 30 elements. Then it will be very easy one. Okay. Right. So first one, types of bonding. We studied. What is bonding actually? Bonding means? Bonding means nothing but force of attraction, that's all. Force of attraction between the 2 atoms, isn't it? Okay, between the molecules or between the atoms. That force of kind of attraction is called, we can say, bonding. Okay, so how the bonding formed means here, by transfer of electron or sharing of electron or sharing done by any one of the atom, anyhow transfer of electron, sharing of electron. So then only the bond will be formed. Understood? Okay. So this is all we are going to study. First one, that types of bond. Types of bond means, tell me, what are the types of bond? We have ionic bond, covalent bond, I told you, right. So first ones here, okay. First topic is, types of bond. So under this we have ionic bond. What is the other name for ionic bond? Electrovalent bond. Understood? It's called electrovalent bond. So simple. So one example. What is it? What is this? One examples of this each and every one. So ionic bond means ions are the bond between ions. That's what is called ionic bond. The bond or force of attraction between ions. Ions nothing but it's a charged particle. Plus and minus will be there. Understood? So there is a force of attraction between cation and anion. That is called ionic bond. How the ions are produced from an atom means, suppose best example I am taking sodium chloride. You take sodium chloride, sodium chloride. Okay, this is example. Okay. So sodium 2,8, 1. This is a configuration. No? This is 2, 8, 7. Okay. So before this is all bonding, if you want to study, here we must know one rule. What is the rule? You know that. What is the rule? Octet rule. Do you know that? Okay. What is oct means? 8. So the elements maintaining 8 electrons in the outermost orbit to become stable. Okay. So these are all unstable. Why? Because here, this is ready to react. Because by lose one electron, it is readily lose electron, it is readily gain electron. Okay. After readily lose electron, readily gain electron, that process done means it becomes stable. Okay. Understood? Still it will become unstable. Okay. It's ready to react. Okay. If it is stable means that's all. Reactivity will be somewhat less. Okay. So oct means the element maintaining 8 electrons in the outermost orbit. Okay. Understood? That's called, maintain 8 electrons in the outermost orbit. That's called what? Octet rule. Now no one having 8 electrons in the outermost orbit, no. This having what? 1 electron. This outermost. It's called outermost, no. Outermost, last cell. This also last cell. Okay. For maintaining both are maintaining 8 electrons in the outermost shell. What happens? Complete transfer of electron from one valence shell to another valence shell. Okay. Then only what? It has given how many electron? 1. So 1 plus. Remaining 2 comma 8. Understood? It gains how many electron? 1 electron. So 1 minus. If it lose electron, 1 plus. If it gains electron, 1 minus. Understood? You know that. Now after gain it becomes what? 2 comma 8 comma 8. Understood? Now both getting what? Both getting octet configuration. Understood? Get or not? Understood? Both. This also getting 8 now. This also getting 8 now. So both getting octet configuration. Now after that there will be a charge formed between them. No. This is called cation. Understood? This is called cation. This is called what? Anions. Okay. Now charges are produced. Now you know that there's a force of attraction between this and this. So the force between the ions, no, that's it's called what? Ionic bond. Are you following? Understood? So this is one example, or we can say electrovalent bond. Electron completely transfer from one valence shell to another valence shell. Electron completely transfer. Okay, that's why electrovalent bond. Okay, understood. The valence last cell means you know the valence cell. Understood? Right. So many examples we can see. Suppose here we can say calcium chloride. This is one example. Calcium chloride means here calcium chlorine 2 times, right? Calcium is what? 2 comma 8 comma 8 comma 2. The configuration you must know. It will be easy. Chlorine as usual you know that 2 comma 8 comma 2 comma 8 comma 7. Okay. Our aim is to get octet configuration. So how many electrons it readily giving? 2. 1, 2. Here we have 2 electrons. No. One is given to this chlorine. Another one is given to this chlorine. Understood? Now after electrons is given, now it becomes what? 2 comma 8 comma 8 only. It has given 2 electron. No. 2 plus. It has given 2 electron, but this chlorine receive only 1 electron. Then I put 1 minus R. Okay. This also receive 1 electron. Then I put 1 minus R. Now both getting octet configuration. 2 comma 8 comma 8 comma 8. Understood? Are you following? Okay. Now that's all. No. How we can write simplified form means Ca2 plus 2 times Cl minus. No. Cl minus 2 times Cl minus. Understood? So that's all simple. Calcium chloride out. It's a it is an electrolyte. It's ionic compound. It's electrovalent compound. Okay. When we add water to this, it is split into ions. Okay. Then only it conducts electricity in liquid state. Understood? Ions are produced. No. Okay. Right. Ca2 plus. Okay. Now you know that 2 comma 8 comma 8 means what? Which configuration? Whose configuration? That is argon. Isn't it? Do you know that? This is called what? This also argon configuration. This also what? Argon. 2 comma 8 comma 8 means it's called what? Atomic number is what? 18. So argon configuration. Understood? So this is one bond. Just remember. Okay. You want me to just copy them? Be quick. Or you can understand means leave it. Understood? Just write one examples. At least really knows something about that. Okay. What is electrovalent bond? What is ionic bond? You must know. Okay. If you want me, just write the definition. Simplify form I'll give. Complete transfer of electron. Complete transfer of electron from one valence shell to another valence shell. From one valence shell to another. This is all. This is a short form of writing. Complete transfer of electron from one valence shell to another valence shell is called what? Ionic bond. That's the definition. Understood? Next one is, so many examples are there. Okay, so you can try. If you have time, means you can try so many examples here. You just note on. Example is CaO, MgO, okay, magnesium chloride, okay, understood. Potassium chloride. So many examples you can give. Okay. These are the examples you can try later. Okay. Na2O. After electron transfer, both the species getting octet configuration. Okay, one is giving electron, then only I put positive charge. One is receiving electron, then only I put negative charge. Understood? So one of the type of bond. Okay. Next. Other examples, just know you try yourself. Okay. Sometimes they'll ask, find out the ionic bond, ionic compound among the following. Yeah, these are all ionic compounds. Okay. Right. Next one, written all this. Right. Second one, covalent bond. Covalent bond. Okay. See that? B, that's called, covalent bond. Covalent bond. Okay. Nothing but here simply we can say mutual sharing. Covalent means, sharing of electron. Mutual sharing, that word is important. Mutual sharing of electron. Okay. Mutual sharing of electron between what? Two atoms. Understood? Okay. Suppose simple example is, you take H2 outright, HH. Understood? So this hydrogen giving one electron, this hydrogen also giving one electron. So hydrogen atom number only one, no. Yeah, just listen after that you can write. Now mutual sharing of electron between two atoms. Understood? So one pair is present, no? One pair. Then only what? Yes. No. Okay. Okay. See, covalent bond means, mutual sharing of electron between two atoms. Example H2, HH we can write. This hydrogen is given electron, this hydrogen is given electron. So one pair is present now in between. Okay. So we can write single. It's called what? Single. One pair is present between the two atoms means what? Single covalent bond. Correct or not? Okay. Suppose O2. O2 molecule. OO we can write, no? Okay. Then see oxygen atomic number 8. 2 comma 6 we can split, isn't it? 2 comma 6. Understood? Okay. How many electrons it is going to share? How to find out? Suppose hydrogen, helium, lithium. Tell me, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Isn't it? It's order, clear. Atom number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct or not? Okay. Sharing means here it can share one. Okay, it can share only two electrons outmost orbit. Two here it will not share anyone. It's a inert. Here 2 comma 1, 3 will have to split. 2 comma 1. So 1 only valence electron. 2 comma 2, 2 can share. It can share 3. It can share 4. 7 out to split. 2 comma 5 no. Okay. This is 2 comma 4. So 4. This 2 comma 5 na don't say 5. 5 valence electron 5. But sharing. Are you following? Valence electron 4. Sharing also 4. Valence electron 5. But sharing will be, if it is more than 4 means you just remember it is, you just write 8 minus 5. So what? How many electrons you can be able to share? 3 only. It comes down. 8 means how to split 2 comma 6. 8 minus 6. How many electrons share? 2. 9. So what? 2 comma 7. 8 minus 7. How many electrons it can share? 1. Okay. This is what? 8 comma, so 2 comma 8 no. So that is more than 5 means you just subtract. 8 minus 8 no. It not share 0. Like this going, it goes on. Understand? So sharing very very important. Okay. So oxygen means it can share maximum 2 electrons only it can share. Okay. So this oxygen can share 2 na. This also can share what? 2 electrons. Understood? Are you following? Okay. Okay. But actually how many electron? 6 electron. Among 6 electron it can share 2 only. Understood? It can share only 2. Remaining 4. Only 6 electron we have. That is, it can share only 2. Remaining we have 4. We can put 4 here. Understood? Here also same no. 1, 2, 3, 4. Understood? Right. If we put circle means it obeys, octet row. 2, 4, 6, 8. This pair is common, no mutual sharing, mutual. It has given 2. This also has given 2. Okay. So how many pair in between? A, because you just remember A intersection B. No. Yeah. So how many pair in between? How many pair? 2 pair. 2 pair means you put bond like this. Double colon bond. Single pair no. I put one single bond. Here 2 pairs no. Then I put double. So this is called what? We can say simply, we can say what? Double colon bond. It goes on. Understood? Then N2. Here I put on N. Here I put N. Understood? The sharing only you must know. Okay, 2 comma 5 you can split. Sharing means how many electrons it can share means 3 only. This concept we must know. Understood? 3 only it can share. Even though it has 5 valence electron, but it can share only 3. So it can share 3 means this also can share what? 3. Correct or not? Among 5 valence electron, it can share only 3, remaining 2. Are you following? Put it here, remaining 2. So here also remaining 2. Understood? Then you put circle. Correct or not? Each and every circle we have 8 electrons. Understood? This circle also we have 8 electrons. So it obeys octet rule. It's also we have 8 electrons. It obeys octet rule. Now how many pair? 3 pairs. Understood? Then only we put what? Triple colon bond. Understood? Triple colon bond. It goes on like that. Okay? Just note down. Be quick. Types of bond. One space. He leaves one space, ma. What's her name? Okay. He leave one space. Actually, first one is ionic bond. Okay. Second only. Okay. Leave one. Only half page is enough. Covalent bond. First write the definition. What is covalent bond? Mutual sharing of electron between 2 atoms. It's called covalent bond. This and all, if you want me, you put circle like this. Okay, you put circle like this. Here in each and every circle we have 2 electron only is there. No, then only we can say it's called 8 electron means we can say octet, isn't it? 8 electrons means we can say octet, but 2 electrons means we can say duplet. Duplet, understood? Understood? Easy one. Here, hydrogen, we are going to study here bond order and all later. Okay, so here bond order 3 because 3 bond is there. Here bond order 2. Okay, here bond order 1. Understood? Written all this. Okay, write fast. Just copy them. This is very important. Just note down all this. Just understand and study. Okay. This is a diatic molecule, simple molecule. Yeah, understood. Can I rub this? Okay. I written this one, this part. Okay. So I'll give one more examples. It's a very simple example. Methane. Who is the middle? Who is present in the middle element? In methane, carbon in the middle, no? Carbon in the middle, isn't it? The structure will be like this, no? You know that, we studied. Yeah. Okay, you know everything. I'm recalling your answers, okay? Okay. Then, carbon, atomic number, I given here 6, 2, 4. Here up to this, valence electron increase 1, 2, 3, 4. Sharing electrons also 1, 2, 3, 4. But after that, everything will be decreases. Okay, sharing will be decreases. Okay, so like as here 2, 4, no? 2, 4. Got or not? Okay. Okay. See, carbon can share 4 electron, but the sharing depends upon only the outermost atom. Okay, it can give 4, but it cannot able to give 4, no? Okay, so here sharing can be decided by only who is deciding. The outermost electrons only can decide. Hydrogen can share only 1 electron. Then only carbon also can share 1 electron. Okay, even though it has more number of sharing electron, it cannot, sharing that who is the deciding factor means only the outermost electron, outermost atom. Okay, so this carbon, okay, this hydrogen can give 1 electron, no? The carbon also can give 1. Hydrogen can give 1, is also, okay, right. Are you following? Okay, and then you put circle. So this is, that simple is and all. Understood? If you want to put center means, put like this. Are you following? Okay, so here all are how many pair? Only 1 pair. Then I put what? Single covalent bond. 4 single covalent bond will be there. Understood? Right. So this one is called what? What is this? It's called only tropate octet rule. But this is all what? Only 2 electrons, no? It's called what? Duplet. Duplet rule. Okay, right. Note down. Just note down. So based upon this, you go through other structure also. one more examples I'll give, and after that you do. I'll give some more examples. You can do it in your home later. Okay. Then water. Water how to do? First of all, see the middle element. Who is the middle in water molecule? Mostly one element. No, if you have more number of atoms, means always it will be surrounding. Okay, it will be in surround. Okay, if you have one atom, means number of atoms here. Oxygen is only one atom. Yeah. So it always in the middle. No. Okay, understood. So more number of atoms means always it is present around this. Okay, only one atom means always it will be center. Okay, simply remember O. Okay, this one hydrogen, this one hydrogen I put. Okay, hydrogen can share one. It can able to share only one. So then only oxygen also can share one. And this hydrogen can share one. This also. Okay, understood. Okay, but oxygen totally how many valence electron? 6. Among 6, it shared what? This side one, this side one. Understood? Okay, oxygen shared only one electron to hydrogen, this one electron to this hydrogen. So among 6 valence electron, 2 electrons are shared. Remaining, we put what? 4. Understood? Are you following? Okay. So here, these electrons are involved in bond. No, that's why it's called bond pair of electron. Understood? These 2 electrons not involved in bond formation. No, that's why it's called lone pair of electron. Okay. So first I put circle. You know that. Are you following? Okay. See, this electron involved in bond. No, then we can say what? Bond pair of electron. Are you following? It's not involved in bond form. Simply I put this is, we can say what? Lone pair of electron. Okay, right. Understood? Just note down. Then only the structure how to put what is the bond, how the bond will be. It will be like this. Understood? Here only bond. No, here this pair is present as it is. Okay, this is called lone pair. Okay. Then only we can say water molecule is a V shape. So we will be studying later. Okay. So sometimes they'll ask, in water molecule, how many bond pair? How many bond pair? This is one bond pair, this is one bond pair, no? So 2 bond pair, 2 lone pair. Understood? Right. Only one molecule you try, the ammonia molecule, first molecule. Other example you can do it in a home. Only one molecule you can try, ammonia. Any doubt means ask me. Okay. The surrounding atom sharing how many electron? That much only the middle atom can able to share. Okay, understood? If you have polyatomic molecule, okay, surrounding, the deciding factor is surrounding atom only. Okay. Any doubt here? Actually, it's a V shape. We have one theory that we are going to study later. Just copy them, just write down as it is. You can try ammonia molecule. Ammonia, formula is what? NH3, yeah? Okay, right. Now, who is the middle? NH3, nitrogen in the middle, no? So hydrogen I put. Okay, right, understood. So hydrogen can share one electron. So this also can share one electron. Here, understood? This also can share cation. Okay. Then nitrogen, valence electron, 5. 5, yeah. So 3 electrons shall share. Remaining 2 will be the lone pair. Understood? So how to write the bond formation? Bond means you can write N, H, H, H. Okay. Understood? This is called lone pair. Lone pair only they put like this. Okay. Okay. All nitrogen, hydrogen are in the same plane. The lone pair will be in the top of this. Okay. Then only it's called pyramidal. Okay. Nitrogen, understood? Nitrogen and 3 hydrogen are in the same plane. It will be on top of this. It is perpendicular to the plane. Then it's called what? Pyramidal structure. Okay. Just note down. Huh? Pull. Okay. But remember, one nitrogen and 4 hydrogen are in the same plane. If you have one textbook means, the same plane. Okay. Lone pair will be top of this textbook. Okay. Understood? Okay. Understood? Okay. Next one. So just note on all this. Okay, right. Sometimes in structure, the omni bond pair, omni lone pair. So if you know all this, okay, sometimes they lost like this. Okay, in a molecule. So when you draw, after that you can able to say omni lone pair, omni bond pair, and all. Okay. See, one is what? Coordinate bond. Coordinate bond. Coordinate bond or coordinate covalent bond, whatever we can say, coordinate covalent bond or dative bond, other name. Okay. So here, write the definition. It's a bond between donor atom and acceptor atom. It's a bond between, just simply write, bond between donor atom and acceptor atom. Understood? Simply, you can say. Okay. It is represented by arrow mark. It is represented by arrow mark. In bracket right here, donor atoms, I told you, donor atom nothing but, Lewis base and Lewis acid. Understood? Other name, bracket right. Cut or not? Okay. So an example I'll give. Simple. Okay. But covalent bond means only sharing. Each atom can share one. Yeah. This can share one means this also can share, like that. Okay. This can share 2 electron means this also can share 2 electron. So covalent bond, mutual sharing. But here sharing, sharing can be done by only one atom. This will share. This will donate one pair of electron means this will not do anything. Okay. So this is a donor atom, no? So arrow mark comes from donor atom to acceptor atom. Arrow mark comes from donor atom to acceptor atom. Understood? Okay. So best examples, NH3 and BF3. NH3 I would write Can you able to write like NH3? Okay. So here nitrogen I told you. Valence electron 5. But how many electrons are involved in bond formation among 5? 3. Remaining 2. Not involved, no? So among 5, 3 are involved. 2 is a, this is a one pair. Okay. Then boron. Boron trifluoride. Can you able to write like this? Okay. Boron. 3 valence electron. 3 valence electron. It has 3 only. It is given to this 3 fluorine atom and make a bond. Is there any electron? No electron, no. Understood? So if you want to combine these two molecules, who can help? Ammonia only can help, no? This only having one pair. So it is giving this pair to what? Okay. Understood? This will not do anything. Okay. So R comes from donor atom to acceptor atom. Understood? So you can put like this, no? Understood? R comes from donor atom to acceptor atom. Understood? Okay. So how many covalent bond totally? These are all covalent bond. Sharing them. How many covalent bond? Covalent bond. 1, 2, 3, 4, 5. In this molecule, 6. But coordinate bond? Only 1. Understood? Just write all this. Be quick. So here, then only we are saying, who is a donor atom? Who is a donor molecule? This is a donor molecule, no? So, then only ammonia is a Lewis base. BF3 is a Lewis acid. Understood? Are you following? So, we are saying, so most of the organic part, ammonia is a Lewis base. Because it's a donor, it's a donor atom. It's a electron donor. So, then only we can say, this is called what? Ammonia is a Lewis base. Simply they'll ask, among the following, who is the Lewis base? They'll ask, Lewis base, you see the lone pair. If you have lone pair means, the molecule having lone pair means, it's a Lewis base. Okay, so it has no lone pair. So Lewis, what? Acid. Write first. Finished? Types of bond. This only study, then at last we have one more bond is there. Finished? Any molecules having lone pair, we can say it's called Lewis base. Ammonia is a Lewis base. Water molecules having lone pair of electron, it's a Lewis base. Okay. Okay. It comes in coordinate compounds. No, we have coordination compounds. We have one chapter is there. No, this act as a ligand. If you have lone pair means that it acts as a ligand. We studied. Okay, right. Okay. Then I start the new more theory that is called just write VSEPR theory. What is the meaning for this? Valence shell electron pair repulsion theory. Understood? Just write. Valence, just write. Keep on writing. Valence shell electron pair repulsion theory. Understood? Valence shell electron pair repulsion theory. Okay. Okay. So the theory we are going to study about what? The shape and all. Okay, what's the shape of this molecule? Okay, especially shape of the molecules. After bond is formed, after electron involved in bond formation, there's a repulsion among them. Suppose for example, was what is this here? If you take methane molecule, that we study just now. Okay, it's a methane molecule. Okay, this is all are bond pair. Okay, electron, between the bond pair of electron there is a repulsion will be there. Okay, then only all these electrons are apart from each other, are far away from each other. Okay, so among the bond pair of electron there is a repulsion. This also charge negative charge, this also negative charge. Then only after electron involved in bond formation they are all away from each other. Then only if suppose if the three pairs are present like this, trigonal, three pairs of electron like this, what is this? Tetrahedral. Understood? So like this, we anyhow, once electrons involved in bond formation means they are not nearer, they are all far away from each other. So they are all present in or they are all far away from each other from the what? The center atom. Okay. So the two pairs like this, linear like this. Okay. So valence shell electron pair repulsion. Among the electron we have some repulsion will be there. Okay. So then only we can give the shape to the molecules. Understood? Okay. So this simple one here, it is classified into two types. Suppose here see first one, put the heading, you put central atom, or you put like this, simple way. No electrons, no lone pair of electron on central atom. This one category. Okay. After that we are going to study having lone pair of electrons on central atom. Okay. So we have two different kinds of molecules. Okay. See, you make it a column. See, simple one. First you put type, examples, structure. Okay. Bond angle, shape, just very important. Type, example, structure, bond angle, shape. You put like that. Okay. Okay. Type is, listen carefully. So I'll write it. After you can start. That is AB2 type. AB2 type na A is only one atom, B two atoms. Okay, like that. It goes on. See here, like this, AB3 type, AB4 type, AB5 type, AB6 type. AB7 is also there. Okay, simple. Example, Can you take? Can you? AB2 type, kata. AB2 type, beryllium chloride. We can say best example. This beryllium chloride out, right? Who is the middle? Beryllium in the middle, kata. Can you able to, this is a way to draw the structure for this. Understood? What's it's a linear, no? Suppose it makes, in between we have one pair will be there, one pair of electron. In between we have one pair of electron is there, isn't it? So these two bond pair are apart from each other among the repulsion. Okay, they will not nearer, no. Okay, they're all apart from each other. It's a straight line, no? What is straight line angle? Linear angle, straight line angle? 180. You must remember, you can get 180 marks in chemistry. Yeah, understand or not? We have 180 marks. Okay. 180 linear angle or straight line angle, 180. Okay. So shape no linear, yeah. We can say what? Linear shape. Understood? Right. AB3. Boron trifluoride. Best example is called boron trifluoride or boron trichloride. You can say. Outright. Who is the middle? Boron. B. We can put like this. B. F. Cut or not? Okay. We can draw like this only. Because how many bond pair? 3 bond pair. Here 2 bond pair. Understood? Are you following? Okay. So 3 bond pair. The 3 bond pair is not in the middle only. They are all apart from each other. They make a triangle, no? So triangle angle is what? 120. It's called triangular. Correct or not? Triangle. It goes on. Then AB4 best example CH4. C outright. C. Cut off. Cut or not? Okay. The angle is the tetrahedral angle means always 109 degree 28 minutes. Just remember, these are all known value. Okay. Tetrahedral angle means always 109 degree 28 minutes. Okay. 1 degree is equal to 60 minutes. So only here point something is coming. So 109 degree 28 minutes. Okay. It's called tetrahedral angle. Okay. Tetrahedral. Okay. AB5, best example PCl5, passes pentachloride. These are all best example, these are all known angle, known shape. Okay, no changes here. Okay, we are study as it is. Next one I'm going to give. Okay, that only there is a change in shape, change in bond angle, everything, some changes. Okay, now PCl5 means you put on triangle like this. Okay. Positives in the middle, Cl, 1 chlorine top, 1 chlorine down. Okay. Shape is formed, shape trigonal, bipyramidal. 1 top, 1 down, no? It's a trigonal, okay? Bipyramidal. Any one shape they will ask. Okay. Angle, if you see the angle here, 2 different kind of angle we should set. Here inside here one, these are all one plane. This chlorine on top, 1 chlorine down, like that. Okay. So inside we go to 120 and 90, 2 angles we should do. Okay. Then AB6. Best example SF6. Okay. I put SF, 1, 2, 3, 4, 5, 6. Understood? So, understood? S of 6. 6 means here the angle is what? The shape is what? Octahedral. Understood? Here also the most, here 90 only. Just right. Not up. These are all known values. Study all this. Okay, one more type is there. IF7. Okay, IF7. Right. Easy one, very easy one. IF7 means you put one, one pentagon structure, okay, pentagon structure, I in the middle, 1, 2, 3, 4, 5, 6, 7, like that, 1, 2, 3, 4, 5, 6, 7, okay. This is called pentagonal bipyramidal. Pentagonal bipyramidal. Just note down. Simply they'll ask one question, that is the shape of CH4, the shape of SF6. Okay, it's all just memorize as it is. These are all regular structure. Okay, here no lone pair. No, is there any lone pair here? Boron 3 electron in the valence shell. All the 3 electrons are used, consumed. No lone pair. Then I put what? No lone pair of electrons on central atom. This is one kind. Next. The bond angle is going to reduces, no? 180, 120, 109. After that, slightly increases. But when you come from AB2 to AB4, it decreases. You just divide 360 by 5. Inside angle is 360 by 5. What's the value? 360 by 5. But it's not given in a textbook, but angle will be like this. What's the value? It's given in your textbook, not given. Textbook is not also, they didn't give. But inside angle 360 by 5. $72. $72. It's called 72. Okay. Finished. Understand the concept? No lone pair of electron. That's important. Okay. All the electrons are consumed. All the valence electrons are consumed. Another one. Can you go to next one? B. What? Simply having lone pair of electron. Having lone pair of electron. Read fast. Time is short, lesson is long. Do you know that proverb? This proverb is not in any book. Time is short, lesson is long. That proverb is somewhat different one. This is chemistry proverb. Time is short, but lesson is very long. Okay. having lone pair. If you take any molecule having lone pair, so that kind of come under this that kind of molecule come under this structure, come under this category. Understood? Okay. See, very simple. Let's just listen. If you take, it starts from only, AB3 type. Yeah. AB2 we studied. Yeah. Actually type is AB3, but instead of A, I put AB2E. This AB3 only, AB3 under AB3 type, I can write it as what? AB2E type. What is the meaning for this? I replace one atom by, I put E. E is called one lone pair. E represents one lone pair of electron. Understood? Examples. Best example is SO2 molecule. Best example, sulfur dioxide. How to write sulfur dioxide? Sulfur, see, oxygen. I told you. Here around the, oxygen can share how many electron? Oxygen can share. Very important. Otherwise, you cannot any benefit. How much sharing? 2. 2 is very important. 2. It can share 2. So that this also can share 2. Yeah. It can share 2 now, we put double bond. Understood? It can share 2 now, double bond. This also can, double bond will come. We studied already. Sulfur atomic number 16. 2, 8, 6. Come to sulfur. Sulfur can share how many electron now? 4. Totally 4, no. It is given here 2 electron, here 2 electron. Among 6, it is share what? 4. Remaining? 2. That 2 is called one lone pair of electron. Understood? That 2 is called one lone pair of electron. Then I told you, AB2 type, one lone pair. Understood? AB2 type, but having one lone pair. Understood? Okay. Then, one more thing. Before study this, you must know, LP is greater than LP BP is greater than BP BP. What is the meaning for this? What is the meaning for this? LP na lone pair repulsion. Repulsion is greater than lone pair bond pair repulsion is greater than bond pair. Okay. So this only repel more. Okay. See, what is this? Let's compare. This is lone pair. This is called bond pair. So lone pair bond pair repulsion. If you compare these two, LP BP. If you compare these two, BP BP. This is bond pair. This is bond pair. No. So BP BP repulsion is called LP BP repulsion. This LP BP repulsion is more. This repulsion only more. Okay. Actually, it looks like what? Triangular shape. Yeah. Actually, it looks like more, triangular. No. 1, 2, 3. This is also considered atom. One atom is present. So we have 3 atoms around this atom. Okay. This is called triangular angle. Actually, triangular angle, it is what? It is called 120. But due to repulsion, the angle is reduces, becomes what? 190. Due to repulsion, angle is reduces. Okay, if you have lone pair means the angle will be reduces. Okay, due to repulsion. Okay. Though, sir, suppose your atom is present means I am saying it's called triangular. No, but it's no atom is there. Okay, then only we can say it's called bent shape. Are you following? Okay, understood. Are you following? So next one, after you can copy them. It's easy one. Another one. I think here that's all. AB3 we have only one category. Then AB4 type. In AB4 type, AB3E type. Get off. Replace one atom by one lone pair. Understood? Okay. Then best example, ammonia. Best example. Ammonia. N. Tell me. H. Cut off. Ammonia. Atomic number, told there is 7 layer. 2, 5. 2, 5 3 electron bond formation. Remaining 2. 2 means one lone pair. Understood? So the one E, AB3 E type. Correct or not? Okay. Here also atom is present means tetrahedral, but here no atoms. Yeah. So so what? Actually, it looks like tetrahedral. It's a tetrahedral angle, no? AB4 no tetrahedral angle. What is tetrahedral angle? 109 degree, 28 minutes. But due to lone pair, it changes into what? 107 degree. Are you following? Due to repulsion. Which repulsion is more? These are all bond pair repulsion. This is called what? Lone pair bond pair repulsion. Understand? Lone pair bond. This also they are asking something 1 mark answer. This order. Okay, right. Therefore, here atom is present means tetrahedral. You know atoms, no? Then only the shape is what? Pyramidal. The question will be like this: the shape of NH3. Lone pair is the present, no? So pyramidal. Okay, understood? Then one more type I will give. After you can write. Then I read it AB2E2. Can you able write like this? AB2E type, E2 type. AB4. Under AB4 we have this also one type. Best example, water molecule. Best example, water molecule. Who is the middle? Oxygen. Correct? Around the oxygen we have two atoms. So why I put one bond? Why a single bond? Hydrogen can share only one electron. Hydrogen can share only one. Then I put single bond. Remaining. Tell me. O 8 2 comma 6 6 le 2 has gone for bond formation. Remaining 4. Remaining 4 means I put like this. Okay. Or I put. Understood? That's E2 type. E2. It is not two lone pair, no. I put E2 type. Are you following? Okay. So this also 1, 2, 3, 4. 4 means tetrahedral angle. What is tetrahedral angle? But due to repulsion, no. This is lone pair repulsion. This is lone pair bond pair repulsion. This is bond pair repulsion. Understood? So lone pair among this lone pair repulsion. Sometimes they ask like this. In water molecule, which repulsion is more? Lone pair is there? No. All kind of repulsion is here. Lone pair, bond pair, bond pair. Okay. So lone pair repulsion is more. So then only the angle changes from 109 degree to 28 minutes to 104 degree. Okay. Okay. Right, B shape, or we can say some sort of bent shape also they'll give. Okay, right up, be quick. Right, first. AB3 we have only one type. AB4 we have two types. Right, first. Having lone pair of electrons on central atom. Okay. Then another type, AB5 type. Okay. AB5 type. Can you go? AB5 type. AB third one is AB5 type. Among AB5 type we have AB4E type. Can you say one is ready? Instead of one atom I put one lone pair. Okay. Example, best example, SF4, best example, SF4, sulfur tetrafluoride, best example. Shape is very, very important. Compulsory one questions they'll ask under AB5 type, okay. Okay, see, AB, tell me, outright. See, SF4 means it belongs to what? AB5 type. AB5 type means what's the structure? First you draw the structure for this. Immediately you should draw the structure for this. Yes? Understood? Understood? Yeah. AB5 na, this is the structure. AB6 na, I given no, one box, octahedral structure, you know that. Okay. AB4 na, one structure is there. AB4, no changes in structure. AB5, it belongs to AB5 type. So you put this. Then, yes, how many fluorine? 4 fluorine. But one lone pair is there, no? One lone pair, okay. That one lone pair electrons, where we put? Means that is a one doubtful. Where we put? So which corner we can put means they put only in this place. Then only this molecule is more stable. Then only we are giving the shape to the molecule. Okay. Only one lone pair length. We can put here, any place. But in this side, just remember this bond, horizontal bond is called equatorial bond. Top and bottom, no. This bond is called axial bond. Just remember. Okay. Then only fluorine. Understood? Are you following? Okay. SF4. Correct or not? See now, what's the shape? The shape of this molecule means, you just remember, what is this? What's the shape? Seesaw. Do you remember? Seesaw shape. Seesaw, no? The two persons are hanging up and down, no? You just imagine this structure like this, okay? Here, two legs is there, okay? Here, the two persons are hanging, okay? Then it's called seesaw, correct or not? Okay. Bond angle, what's the bond angle actually? AB5 means, 120 as well as 90, okay? But due to lone pair, the bond angle will be changed. But bond angle is not given, bond angle is going to reduce, bond angle is not given. It reduces from that, okay? This too is very, very important. This is very, very important. Okay, shape of this molecule, okay? Are you following? Then, tell me. AB, tell me. Reduces one. E2 type. Best example is ClF3. ClF3. See? No. This and all, they won't give. This and all. The shape of ClF3, immediately you must know. How to find out this belongs to this category? How to find out this belongs to this category means, chlorine. So how many bond per here? See, AB5 na totally 5, no? Totally 5. 5 BP, 5 bond pair. Yeah. But see, ClF3 na Cl chlorine valence electron. Cl valence electron. Cl valence electron 17, 2, 8, 7. 7 is valence electron. Among 7 valence electron, 3 is what? 3 bond pair. Kata? 3 fluorine is present. Then only 3 bond pair. Among 7 valence electron, 3 electron is only bond formation. Remaining? 4. Remaining 4 means how many lone pair? Remaining 4 electron. So 2 lone pair. Are you following? Okay, 4 electron remaining. That is called 2 lone pair. Understood? So 2 LP, 3 BP, 2 LP. Understood? So 3 plus 2, 5. This is 5 type. This is 5 type category. Then only you can draw this the structure. Which structure? The same structure. Understood? Cl in the middle. Kata? 3 fluorine. Where we put the clone pair means they put here. Then only stable. Just memorize this. They put in different places. The molecule, which molecule? The molecule is stable due to presence of lone pair of electrons in equatorial bond. Now, fluorine. F here. Then this. What is the shape of this? Here only atom is present. No. T shape. Understood? It's called T shape. T shape, very, very important. T shape. Right now. The only one molecule they'll give how many bond pair, how many lone pair, what's the shape of this molecule, what category it belongs to. Okay. Any question we can expect. Understood? First of all, you should know this molecule belongs to which category. Then only you can able to study other thing. Especially they're giving directly the shape, or mostly they're asking not one question they'll give. They'll give 4 questions in one question. Match the following. They'll give like this: shape of SF4, CLF3, then we have to match them. Okay. So in one question we have 4 choose will be there. If you match correctly, we can get 1 marks. There's one question will be correct. That's the meaning. T shape, no? Put by pencil like this. This is T shape. Here and all I didn't put anything. Okay. Yeah, here atom, wherever atom is present, then only I put this line, no, bond line. Bond angle is 120, yeah. Bond angle, we cannot say correctly. No, when compared to here, this bond angle so much reduces because what? Here 1 lone pair, here 2 lone pair. So again, this bond angle is going to reduce. Okay, when compared to this is somewhat more bond angle, somewhat less bond angle here, due to 2 lone pair of electron. Then one more type, right? Fast. AB, tell me. AB2, E3 type. Okay, AB2, E3 type. It's not given in a textbook. Then you have write IF2. IF2 minus. IF2 minus. So I 2, yeah, 2 is present. So what? Bond pair 2 BP, yeah. Okay. Iodine, fluorine, chlorine, bromine. Everyone having valence electron what? 7. Valence electron 7. Out of 7 valence electron 7. But 1 more minus is there, no? Still here, I didn't put any minus and all. This molecule I put minus. Minus means here extra 1 electron. Actually 7 valence electron. But 7 plus 1, 8 valence electron. 8 valence electron, 2 invalent bond formation. Remaining 6. 6 electron means how many bond pair? 3 BP. Correct? Understood? 3 BP. So 2 plus 3. Sorry. It's called lone pair. Sorry. It's called lone pair. Then only 2 plus 3. That category, no. 2 plus 3 means it belongs to AB5 type category. Okay. Then only immediately you draw the structure. This is a structure for that. 2 plus 3, 5 type category. This is a structure. Okay. Kata. Then I in the middle. 1, 2, 3, 4, 5. Where we put iodine, fluorine means here they put. Mostly they put in lone pair only the equatorial bond. How many BP? 3 BP. The 1, 2, 3, 4, 5, 6. Okay. Then Shape means only what? Wherever the atom is present, it looks like what? Straight, no? Straight. It's called, then it's called what? Linear. Next. Very important that shape of this molecule they'll ask. It belongs to which category you must find out. 3 plus 2, 2 plus 3, yeah. This is what? 4 plus, are you following? 4 atoms is there. So 4 BP plus 1 LP. Totally 5, no. So this belongs to this category. Okay. Okay. Finished? You see the paper from last 5-year papers. Compulsory 2 questions from this to this chapter. Okay. Right. Next one. What type? Tell me. AB. Under AB6 type. Okay. We have what category? AB5 E type. Then AB4 E22. This only 2 categories there. AB. Okay. Understood. Example. Tell me example in your textbook. Example. IF7, IF5 is given. IF5 is given. It's also AB5. Example IF5 we can say. Correct or not? I told you, no? How many bond pair? 5 atoms is there. So, 5, it belongs to what? 5 BP plus iodine. Iodine, all are valence electron what? 7. Yeah, 7 valence electron. 5 invalent bond formation. Remaining 2. 2 means what? 1 lone pair. So 5 plus 1, it belongs to AB6 type. Correct? Understood? Then, what's the structure? This is the structure I told you, no? Octahedral structure. I, correct or not? 1, 2, 3, 4, 5, 6. Correct? Immediately, you should, last time we had done different structure. AB5 means, or AB6 means this is the structure. Understood?
Yeah, 1 second.
Yes.
Three girls have joined now.
Yes, sir.
Let us do a crash course.
Oh, okay.
So we have to finish the whole cycle within 15 days.
Okay.
After we have to give a lot of MCQs. They come
Okay.
late.
Oh, okay.
But sir, need to it's physics, sir. We got to go in pace with ours.
Okay, sir. Yes, yes.
இப்போ ஜாயின் பண்ண பிள்ளைகளுக்கு அவங்க என்ன வேணும்னு பார்த்து பண்ணிடுறோம்.
Okay. Understood. IF5 na first you find out which category that belongs. Then first find out the bond pair. Bond pair and lone pair na 5 plus 1 6 type AB6 na immediately we draw the structure. Understood? Then one lone pair I put it down or no problem here. Okay, right. Tell me. IF kata IF5. Understood? Here also an atom is present, means called, what is the regular shape? Octahedral. Regular shape is octahedral, but on lone pair is coming, no. Then it's called what? Square pyramidal. Here also atom is present, means octahedral, but no atom instead of this, so it's called square pyramidal. Understood? Square pyramidal. Are you following? Square. One pyramid. this not considered. Okay, right. Now tell me here. What's the example? Xenon, I think xenon F4. Kata? Tell me. I'm saying no. Fluorine, chlorine, bromine, iodine. All are valence electron is what? Valence electron is what? 7777. Kata not? Okay. Then likewise, neon, argon, krypton, 8. Xenon. All are what? It's like 8 electron. Remember? 8 electron. Okay. Right. Now, so xenon in the middle, no? Okay. It has valence electrons 8. Now, tell me, bond pair? 4? 4 BP. Kata? Right. Tell me. Then, valence electron 7, 8 le 4 electron bond formation. Remaining? 4 is there. 4 electron means 2 lone pair. So 2 BP. Kata not? Sorry. LP. Right? Understood? So 4 plus 2, 6 type. This belongs to 6 type category. Yeah. They will simply give. First you find out what category it belongs to. Understood? After only we can decide the structure and all. So it belongs to this category, no? Immediately you draw the structure. Cut or not? Tell me. Xenon 1, 2, 3, 4. Cut. 4 fluorine, no? That 4 fluorine only in corner. Here, what? How many lone pair? 2 lone pair. Understood? So here also atom is present means octahedral. But no atoms. Only this place only we have atoms are there. This is called what? Square? Square planar. Are you following? Square planar. Understood? Right. Right first. Be quick.
Lone pair வெளிய போறது ஸ்டேபிளா இருக்குமா சார்?
Lone pair is unstable தான். The shape and all we can say about this only. Shape can be explained only by the atoms, not lone pair. The lone pair always we can put top as well as bottom. This is a planar molecule. This is a planar molecule. It's a planar molecule means all the one xenon and 4 fluorine in the same plane. One lone pair here, one lone pair down. Okay. Okay, please do. Then, I think this one is given in a textbook. Okay. Okay. These are all examples. Last class also we studied HCOF4. It also belongs to this category. Another example, the same things, both are same lone pair, both are having the same structure, xenon OF4. Okay. Finished? Are you following? Only shape, only they'll ask, okay, match the following. That kind of questions we can expect here, okay? So, next one is, before the heading, another one simple topic. molecular orbital theory. Molecular orbital theory. Okay. You know what is molecule? Atoms are together is called molecules. No. Okay. Here molecular orbital means two atomic orbitals combined. Suppose here I am saying atom plus atom, atom plus atom. You know what is this? Molecule. You know. Yeah. Some postulates you just I will give some important postulates of that theory. Okay. Like this atomic orbital plus atomic orbital. Understood? Molecular orbital. That's the definition they are saying. What is molecular orbital means? Combination of two atomic orbitals called what? Molecular orbital. Okay. Suppose here we have types. What are the types of molecular orbital means? We have bonding molecular orbital. We have anti-bonding molecular orbital. Bonding means energy is less. Energy is less energy. Okay. Or simply we can say less energy, more energy. Less energy, more energy. Okay. It is represented by sigma, pi, delta. Representation, bonding. This is called if you put star, pi star, delta star means called anti-bonding. Energy is somewhat high, that's all. Okay. Then, okay. Then, we studied, the last lesson, structure of atom last year, 11th standard portions. When you write the electronic configuration, 1s, 2s, 2p like this, we are writing, no? Yeah. So, now 1s, 2s, 2p, 3s, 3p, it goes on, no? Okay. This one having less energy. Then when you go from left to right, energy increases, no? Okay. That rule is called what? Half-of principle. Okay. Orbitals are arranged according to the increasing order of their energy. It's called half-of principle. Okay. The same principle you can apply for here also. Okay, understood. Then Hund's rule. Each and every pairing does not taking place until all the orbitals having at least one electron each. Hund's rule we can follow, half-of principle we can follow, Pauli exclusion principle we can follow. When you arrange the molecular orbital, this is called atomic orbital. But our aim, we are studying what? Molecular orbital. Na we put this symbol in front of that. That's a small difference. Okay. So we are arranging just like we are all arranging the molecular orbital. But what principle we are following means all the principle. What's the principle? Follow. Just right. Follow. Half-of principle. Okay. Half-Bob principle. And then Pauli exclusion principle. Okay. Next one. Hund's rule. Okay. Hund's rule. Okay. All the principles are used to follow. We can arrange the orbitals. Okay. Just copy them. Other points you just go through in a textbook. So I will give some most important points. Follow half-of principle, Pauli exclusion principle, Hund's rule. Based upon this, we are arranging the molecular orbital. Understood? These are all just go through, but application only very important. Okay, so it's not so important. Okay, finished. If you want to arrange the orbitals, or if you want to electron is filled in the orbital, this rule we should follow. That's all. Okay, right. Just write application. What are the applications? Applications. Okay. Applications, simple. First application is what? Bond order. What's the bond order formula? 1/2 NB minus N of A. What's the most important aim of this theory means to find the bond in between the two atoms. How many bonds are there? Okay, how many bonds? If two atoms are there, no? In between, how many bonds are there? That's called bond order. Half the difference between number of electron in bonding molecular orbital, number of electron in anti-bonding molecular orbital. This is the formula. Okay, so NB. Just write one by one. Right. Start. What is NB means? What? Number of electron in bonding molecular orbital. Cut off. N of A na? Number of electron in antibonding molecular orbital. Understood? Next one. See, bond order is directly proportional to stability of the molecule. Stability of the molecule. Understood? Bond order is directly proportional to stability of the molecule. Okay. Understood? Stability na, suppose for example, I am saying hydrogen bond order 1, okay, oxygen bond order 2, nitrogen bond order 3. Okay, who is more stable? Nitrogen. Yeah. Bond order increases, stability of that is also increases. Okay, so this only having 3 bond order. We are going to study. We are going to find out later. 3, yeah. Okay, therefore, who is stable? N2 is more stable. Understood? Okay, this is one application. Then bond order is directly proportional to bond dissociation energy. You study now the hydrogen single bond, oxygen double bond, bonded 2. Yeah, nitrogen triple bond. 3 bond, then I put like this structure. Understood? So here 3 bond is present. No, we have to spend more energy to break the bond. So this only needs more energy. No, yeah. So bond order increases, bond dissociation energy is also increases. Okay. But bond order is inversely proportional to bond length. Okay. What is bond length? What is bond length? Distance between two atoms. Kata? Distance between 2 atoms. See? Next. Following. Only bond, nothing but force of attraction. Here, which force is more? Here, triple bond. No, this here more force. No, more force means these 2 atoms are come closer. No, in this case, the two nitrogen atoms are come closer. So bond length, what is bond length? Bond length means distance between the two atoms. No, this distance is less. No, which distance more? More, less force of attraction. So here the two hydrogens are away from each other. Then oxygen, two oxygen come closer. Two nitrogen again come closer. Okay. So when bond order increases, bond length decreases. Bond order increases, bond length decreases. Yeah, that understood. In this case, I told you here N2 is more stable, but N2 is here what? Stable. Bond length is, who is having less bond length? N2. That's all. Okay. Stability, nitrogen is more stable, but N2 is having as less bond length. Kata. Yes, two atoms are, due to force of attraction more, the two atoms are come closer. Okay, understood? Then only as I am saying, I given this one. Okay, bond order is inversely proportional to bond length. Okay, that's all. Then one more point I'll give. If you have unpaired electron, just note down. If you have unpaired electrons, we can say what character? Paramagnetic. If you have paired electrons, means what? Diamagnetic. Understood? That's all. These are the points you must know. Now then only we can able to study the examples. Okay. Following. Unpaired electrons, paramagnetic. Paired electrons, diamagnetic. Okay. I complete this only. Okay. This theory part. Understood? Still seeing examples, you don't know anything about this. Okay, just but you must know this information. Then only you can able to study the examples very clearly. Understood? What's the bond order formula? 1 by 2 NB minus N of A. Then when you write then we are getting an answer. No, from the answer we decide. Bond order is decide. If any bond order is more, means that it's more stable. Bond order is more means bond length is very less, inversely proportional. Okay, right. Now come to example. Have you written all this? Right. Okay. Before study this, you just note down write down very important molecular orbital arrangements. Molecular orbital arrangement. I told you, just listen. See, I told you, 1s, 2s, 2p. Yeah. But instead of this, you put sigma 1s, sigma star 1s. Bonding, antibonding. Star na antibonding. Next one, listen. Sigma 2s, sigma star, bonding, antibonding. Then come to pi orbitals. Pi 2px is equal to pi 2py, then sigma 2pz. What's the meaning? Means xyz. Remember, the px py orbitals having same energy. Then I put is equal to symbol. Okay. Then this whenever z comes, means the z orbitals are overlapped together in straight way. Then only sigma bond will be formed. Yeah. So what is the shape of p orbital? P orbital shape. S orbital shape is what? Spherical. P orbital shape is what? Dumbbell shape. Correct or not? Dumbbell. Okay. When two p orbitals are overlapped straight away, which bond is formed? Sigma bond is formed. Correct? When two p orbitals overlap in this way, which bond is formed? Pi bond is formed. Sideways overlapping. This is called what? Straight away they are overlapped. Head-on overlapping. It's called head-on. Okay. And two Z orbitals always overlap in this way. Then only it's called sigma bond. Okay. Just remember. See here I didn't put any star. No star, no. These are all bonding molecular orbital. I told bonding, antibonding, bonding, antibonding. But these are all bonding. Then I'm going to put antibonding. See, pi star to px, which is equal to pi star to py, then sigma star to pz. Okay, to pz. Okay, understood? Right. See, increase this. Who is having more energy? Last one, sigma star. This is also one mark answer. Okay, who is having less energy? Sigma 1s. Okay, increasing. But these two having equal energy, then I put is equal symbol. Okay, it goes on. Okay, this rule. This arrangement we should follow. Atomic number up to 14. Up to 14 we can follow this rule. Okay. More than 14 means a small change in trend. Small changes down. See, listen. It's very important. Sigma 1s, sigma star 1s. Sigma 2s, listen. Star, here only small changes. See, it comes first, then after that this. Okay, you should write second one, this one. Right, tell me. Sigma to pz, then pi to px is equal to pi to py. Kata. No changes. These two only changes. Then I put underline. Then after that you write as it is what? Sigma star to px as it is. No changes. After that, sigma. Kata. Atomic number. Tell me. Atomic number above 14. Can you write? Okay. Up to 14. This is we can say what? Above 14. Understood? Just copy them. Be quick. Copy them. If you have star means anti-bonding. No star means bonding. Okay. That you know. Then only because we are going to give the electrons to the orbital. Okay. Just memorize this one. Memorize. This is XYZ. Pi to px, pi to py, sigma to pz. Then fully star means anti-bonding. Okay. If you know all these examples, nothing. Very simple. Okay. Finished? Okay, listen. This arrangement just keep in mind. Okay. See, one example I'll give. See, example, H2 molecule. H2 molecule, whether it is paramagnetic, diamagnetic, bond order, okay, configuration, these are all the laws. Simple, Now, in one hydrogen, how many hydrogen here? One hydrogen, one electron, two hydrogen. So total electron in H2 what? 2. Kata? 2 then total electron in H2 is 2. Okay. So 2 electrons are these arrangements. The 2 electron how to fill up? How to fill up? Here the lowest layer. All orbitals have we should give only 2 electrons. Each and every orbital we should give 2 electrons. We have only 2 electrons. How to give? Sigma 1s 2. We have 2 electrons. That 2 electron I fill up here only. More than 2 means I can take these orbitals. Understood? Right. What's the bond order? What's the formula for bond order?
1/2.
Bond order is equal to 1/2 NB minus N of A. NB na, this is called NB, this is called N of A. Again NB, N of A. It goes on. Understood? Right. NB having how many electron? Here. This is the configuration, no? So NB we have 2. N of A, nothing. No electrons. Yeah, understood? You have to see this only. NB, 2 electrons. So 1/2, 2 minus answer 1. Kata. So bond order is what? 1. Okay. So what? What bond? Single covalent bond. Yeah. So 1 means I can write like this. H single bond H. Yeah. Okay. What character? What character? If you have 1 electrons means paramagnetic. 2 electrons is present. No. So what? It's called diamagnetic. Paired electron. Yeah. Right fast. For hydrogen molecule, these are the information we can give. Right fast. Harini is attending my class. This is the second time. So she is going to get marks, 360 marks in chemistry. Isn't it? Okay, right. Any doubt here? Now, easy one. Question will be like this. Helium-2 is a diamagnetic or paramagnetic? Question. Yeah. So, you must know all this. Yeah, helium-2. You can try. Just listen for 1 minute. The same principle. First point. Total electron in helium-2. 1 helium, 2 electrons, total of 4 electrons. Therefore, electronic configuration, tell me. We have 4 electrons, that we can put it here, no? Here 2, here 2. So, sigma 1s, 2, sigma star 1s, 2. Right. Then bond order 1/2 NB minus N of A. Understood? This is bonding and anti-bonding. Here 2, here also 2. What? 1/2, 2 minus 2, what? 0. Understood? Okay. 0 means, is there any bond? One single bond, covalent bond. No bond, no? No bond. No bond. No bond. Then only we can say this molecule does not exist. Okay. Then only bond order 0, no. Question will be like this. Why helium-2 does not exist now? Bond order is 0. Therefore, I simply write helium-2 does not exist. Are you following? because bond order is 0. Understood? Right. What character? Here also 2, here also 2. No single electron. So this is also diamagnetic. Right fast? Right fast.
இது சம டயக்ராம் வச்சு கூட போடுவாங்க.
Diagram. And but these are diagram they won't ask. Okay. Then these are information you must know. Then only I put this. I am teaching in this way. Just remember this part is very important. Okay. These are a very small molecule. When you go to O2 molecule, N2 molecule, F2 molecule, somewhat different one. Finished? Likewise, just note down. Why Be2 does not exist? Be2. Be2 na beryllium 2, kata does not exist. Because this also what? You leave some space, you write all this also 0 will be getting. Bond order is 0. Okay? You leave some space. Then go to next one. If you write continuously means, okay. So this also answer, you just go, leave some space. When you go through, you can practice in that place. Understood? Right. Next one. Next one, another exam, fourth one, N2 molecule, very important. N2. In N, how many? What is the atomic number for nitrogen? 7. Kata? 7. How many? As usual, same step. Total electron in N2. 7 plus 7? 40. Kata? Right. Electronic configuration, no? This 14, no? Which arrangements we can follow? These arrangements, up to. Kata? Can you fill up? 2, 2, 2, 2. Yes, I'll write. Tell me. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Here, fill up. But how to fill up means this, these two orbits having same energy. So 1, 1, 2, 2 like that. Okay. But in this case now we have more amount of electron. That's what. Tell me. Pi 2px2 is equal to pi 2py2. Kata? Still how much? 2, 4, 6, 8, 10, 12. Kata? Again, we need 14, no? Sigma 2pz2. Kata?
3 P orbital. P orbital 6 வரைக்கும் போடலாம்ல சார்.
3 orbitals.
P orbital. 6 வரைக்கும் fill பண்ணலாம்ல சார். இந்த 3 3 கூட
P orbital P 2p 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 total 6. P orbital split it into 2px 2py 2pz. Yeah. Then only each and every orbital we can put maximum 2 2 2 only. Understood? So now 14 or not? 14 now we get 14, no? Kata? Okay. Now tell me NB, N of A, tell me. NB na? No star. 2, 4, 6, 8, 10. Kata? No star. N of A na? 2, 4 star. Okay, understood? 4. Now what's the formula? Bond order 1/2 NB minus N of A. So what? 1/2 10 minus 4. So 6/2 answer 3. 3 means what? N triple bond N. Kata? N triple bond N. Sure. That's all. Tell me, what character? See that? All are all are paired. So what? It is diamagnetic. Questions, N2 molecule is or which is diamagnetic among the following? N2, O2, H2, like that. Okay. So we have to find out like this. Right fast. Do this next one, O2. Be quick. O2 and O2 N2 plus. Any doubt? Please work out in your note. Then only it will work. Practice. Okay, practice more. I am practicing every year 10 times. Okay. Okay. I am practicing every year 10 times. Minimum 10 times. Maximum depends on the batch. Okay. See, N2 is, N2, sometimes they'll ask N2 plus. Right fast. N2, okay, finish this one. Right, be quick. Right fast. These are the questions they'll ask. What is the bond order of nitrogen? What is character of nitrogen? Okay. These two informations here, there sometimes they'll ask configuration. Okay. Tell me. N2 plus na? Plus na what? N2 la 14, but N2 plus la 1 electron has gone. N2 plus na loss of what? Loss of 1 electron. So therefore N2 having how many electron? 13. Correct or not? Okay, 13. 13 only we can fill up. So how to fill up? You just imagine. Okay, I am not going to fill up everything. You just imagine 1 electron lost na. It's the first it's the last electron. No. Here 1 will come. Here 1 will come means what? Tell me the bond order. Bond order is equal to 1 by 2 NB minus. So now tell me N of B how much? 9. N of A how much? 9 here? 3. Small changes here only. 4. Okay. NB minus N of A. So 1 by 2. Tell me 9 minus 4. Right. 5 by 2.5. Get up. Paramagnetic. Okay, right. Paramagnetic. Okay. Likewise here you do yourself N2 minus. N2 minus. N2 minus na? How many electron? 15. 15 na? What principle we have to follow? This one. This you have to go this way. Similar only, small changes only, but in this way you follow. Okay? Do it. Homework. Okay? The only one sums I'm going to put. Last one. This one you make it as a homework. This one N2 minus. Okay. Now next one. You all have see now see the O2. O2. Now O2. Total electron in O2 16. Okay. 8 plus 8. This rule. Electronic configuration. Okay, tell me. Sigma 1s2 sigma star 1s2 sigma 2s 2 sigma star. Then listen carefully. Sigma 2p z2 pi star pi 2px 2 is equal to pi 2py 2. Okay. Okay. Next one. How much still we put? 6 6 plus 14. Again 14. Then we came up to this. Clear? We fill up only 14 electron. Then 15 16. You put 15 16 here only. Don't put here only. Then these two orbitals have equal energy. So 15 16. You put like this. So everyone doing this mistake only here. Okay. 15 16 now. How to do? Pi star 2px 1, which is equal to pi star 2py 1. Understood? Okay. If you the 2 electron if you put here means it's called diamagnetic. Now you put separately because these two orbitals have energy also equal. So what kind of character? It is a paramagnetic. We know unpaired electrons, no single electron is there. So para. Okay. Now what's the bond order? Bond order is equal to 1 by 2 Nb minus N of A. So Nb is what? Tell me. N of A is tell me. 2, 4, 6, 8, always 10. Okay. N of A tell me. 2, 4, star here no. Totally 6. Kata? 1 by 2. N 10 minus 4 by 2. 2. Kata? 2. So what bond? Double. Studied. Yeah, double covalent bond. You know. Understood? Character. O2 is what? Due to unpaired electrons, it's paramagnetic, right? Right, fast. Remaining and all, you can make it as a homework. I'll give some homework. O2 minus, O2 2 minus, you can do. Okay, as a homework. Finished? Okay. Here, how many electron? O2 less 16 electron. O2 minus la 17. Here? 18. O2 la 16 electron. O2, 1 minus no. 1 minus no 17. O2 2 minus liya 18 electron. That 18 electron only we should fill up here. Liya. Then find out all this. Understood? Right. Compulsory. Also one question will be there. Okay. Then one more topic here, hybridization and types of bonding. This one I will do in the afternoon. 2 to 3:30 I will take. Okay. So still, okay, have your lunch. Then any doubt means ask me. You do this homework also. Okay. I stop up to this. Okay. Thank you, students.